So, in the last class, we solved some numericals, right? So, were you able to solve the numericals? I told that I will discuss the numericals today.
Yes, sir.
Mhm. Hello. Hello. Can you all hear me?
Sir. Done, I think. That's numerical.
But what about others? I know you did it. What about others? You are very good. You do. Those who all do did it very good. So, did you do the second part and the third part? Many of you gave the answer for the first part. Did you guys do the second part and the third part?
Yes, sir. Yes, sir.
You did, na? And what about others? What about others? Okay, then let's start a different unit today. Okay. After all these units are done, we'll be revising the numericals again. Is it okay for all of you?
Sir.
Can you see the screen?
Sir.
Okay. First of all, let me show you a video. Then I'll show you a screen. Are you able to hear the sound of the video?
No, sir.
No? Wait, wait. Now, now can you hear?
No.
No, sir.
One through each
Now
video
can you
lecture.
hear?
Today's lecture we will study some basics of
Yes,
vibration.
sir.
Let us start.
Okay. So first of all, this will clear your concepts. Then I'll try to explain it to you.
We will study basics of vibration. Vibration is a vast topic in which, or vast area in which various things are included, from which we will study one by one through each video lecture. In today's lecture, we will study some basics of vibration. Let us start. Now, what is a vibration? Now, it is defined as an oscillatory motion of bodies in response to disturbance. Now, if suppose any object is there, if it is disturbed by some external force and then it is removed the force, then there will be some oscillations of that body, and that is called as a vibration. A vibration system involves
किसी का माइक माइक चल रहा है, म्यूट करो ना तुम लोग का. Someone's mic is running on. Please mute your mic.
the transfer of potential energy to kinetic energy and vice versa in alternating fashion. Now, when elastic bodies such as a spring, beam, or any shaft are displaced from equilibrium position, now in this animation you are observing that one spring and mass is there, it is displaced from its mean position or equilibrium position, then it is oscillating about its mean position. Now, if these are displaced from equilibrium position by application of external forces and then release, they execute a vibratory motion. That motion is called as a vibratory motion. Now, this is due to the reason that when a body is displaced, the internal forces in the form of elastic or strain energy are present in the body. At release, these forces brings the body to its original position. When the body reaches equilibrium position, the whole of the elastic or strain energy is converted into kinetic energy. Potential energy is converted into kinetic energy, due to which the body continues to move in the opposite direction. This whole of the kinetic energy is again converted into potential energy, due to which the body again returns to equilibrium position. In this way, the vibratory motion is repeated independently. Now, this vibratory motion has some advantages as well as some disadvantages. Now, this vibratory motion is everywhere, in vehicles, in machineries, in human body, as well as in some musical instruments as well as not some in all musical instruments. Because of these vibrations only, these musical waves are created. Now, these excessive vibrations can have some bad effects as well, such as noise will be created, loosening of fasteners, tool chatter, fatigue failure, and discomfort. N number of such disadvantages or discomforts are there due to this vibration. Now, there are some useful vibrations as well. Now, in compression machine, these vibrations will be useful. Now, in stone breaker, there one human has shown that is breaking the stone with the help of stone breaker with the help of vibration only. Now, ultrasonic cleaning is there. With the help of this vibration only cleaning, we are utilizing it for cleaning purpose. Now, harmful vibrations will create a noise, wear, fatigue. Due to that, your whole assembly or system will destruct or fail. These are some disadvantages of vibration as well. Now, to start with, we have to see some terms used in vibratory motion. And these terms are very important. In further subsequent lecture, we are going to use these terms. That's why you should know the definitions of these terms. First one, period of vibration or time period. It is the time interval after which the motion is repeated itself. Period of vibration is usually expressed in seconds. It is the time after which motion is repeated itself is called as a time period. Cycle. Second is cycle. It is the motion completed during one time period. Third, frequency. It is the number of cycles described in 1 second. Number of cycles described in 1 second. The SI unit of that frequency is hertz, which is represented by capital H suffix Z, which is equal to 1 cycle per second. 1 hertz is equal to 1 cycle per second, and frequency is the number of cycles described in 1 second. Amplitude of motion. Now the maximum displacement of vibratory body or vibrating body from its mean position is called as amplitude of motion. Maximum displacement of a vibrating body from its mean position is called as amplitude of motion. Next is natural frequency. Previously we have studied the definition of frequency. It is nothing but number of cycles described in 1 second. Now here is natural frequency. When no external force acts on the body after giving an initial displacement, then the body is said to be under free vibration or natural vibration. And the frequency of the free vibration is called as a free or natural frequency. What is natural frequency? Frequency of
Hello.
free vibration.
Students, do I need to repeat this again, or are you understanding what is being told?
Sir, repeat it.
Huh?
Repeat.
Repeat.
Yes, sir.
Which one? From first? From the terms? From the first one? First one. Terms used in vibration?
Yes, sir.
Okay, wait.
We have to see some terms used in vibratory motion. And these terms are very important. In further subsequent lecture, we are going to use these terms. That's why you should know the definitions of these terms. First one, period of vibration or time period. It is the time interval after which the motion is repeated itself. Period of vibration is usually expressed in seconds. It is the time after which motion is repeated itself is called as a time period. Cycle. Second is cycle. It is the motion completed during one time period. Third, frequency. It is the number of cycles described in 1 second. Number of cycles described in 1 second. The SI unit of that frequency is hertz, which is represented by capital H suffix Z, which is equal to 1 cycle per second. 1 hertz is equal to 1 cycle per second, and frequency is the number of cycles described in 1 second. Amplitude of motion. Now the maximum displacement of vibratory body or vibrating body from its mean position is called as amplitude of motion. Maximum displacement of a vibrating body from its mean position is called as amplitude of motion. Next is natural frequency. Previously we have studied the definition of frequency. It is nothing but number of cycles described in 1 second. Now here is natural frequency. When no external force acts on the body after giving an initial displacement, then the body is said to be under free vibration or natural vibration. And the frequency of the free vibration is called as a free or natural frequency. What is natural frequency? Frequency of free vibration is called as a natural frequency. Isn't it? Now next is resonance. When the frequency of external force is equal to natural frequency of system. What is natural frequency? When just force is given and it is released, then whatever vibration of the body is called as a free vibration, and the frequency of that free vibration is nothing but a natural frequency. If this natural frequency matches with some external force, continuously applied external force, then the system starts vibrating with the highest amplitude. This condition is called as a resonance. At that time, resonance occurs and the system vibrates with the highest amplitude. Ultimately, the system may fail at the resonance. So we have to avoid this resonance condition. To avoid resonance condition, we must know what is the natural frequency of system. Because if the external forcing frequency comes more than natural frequency, then there will be breakdown of your system. That's why you should know what is the natural frequency of your system to avoid this resonance. Next is damping. Damping is resistance to motion of vibrating body. Resistance to the motion of vibrating body. Now, what are different types of damping? What is the effect of this damping in the vibrating body? That we will study in further lectures as well as in this lecture. We will just only study what is the definition of damping. Damping is nothing but a resistance to the vibration. Next, degrees of freedom. Number of degrees of freedom for a system is the number of kinematically independent variables necessary to completely describe the motion of every particle in the system. Number of independent variable necessary to completely describe the motion of system is nothing but a degrees of freedom. Now, in vibration, it is most important to know what is the degree of freedom of that system so that we can derive one equation based on these degrees of freedom, and we can solve to find displacement, velocity or acceleration, that is the amplitude terms of vibration. Now, there may be a single degree of freedom system, 2 degree of freedom systems, or 3 degree of freedom systems are there in the environment that are occurring. First, we will see the single degree of freedom system. Examples of these two are shown here in first two diagrams, B and C diagrams, in which one spring, one mass is there. C diagram, one disc is attached to one shaft. Now there, in B diagram, spring mass system, that mass has been displaced with distance x, and that x is the only degree to define the motion of the system. That's why it is a single degree of freedom system. In torsional system, one disc is attached to one shaft. If disc is rotated in any direction by angle theta, then it will vibrate along that vertical axis by angle theta, clockwise, anti-clockwise, clockwise, anti-clockwise, like that, with a single degree of freedom. Now, in next example of 2 degrees of freedom system, there I have shown 2 springs and 2 masses, m1 and m2 mass. Now, if m1 mass is displaced by x1 distance, m2 mass is displaced by x2 distance, then the system vibrate with 2 degrees of freedom. That's why this system is having 2 degrees of freedom. In B diagram as well as the torsional system, 2 rotors are at that shaft in 2 sides, and these 2 rotors are twisted. One is clockwise, another on anti-clockwise direction by angle theta 1 and theta 2. Therefore, to describe that system, 2 angular displacements are required, theta 1 and theta 2. The equation of motion will be based on these theta 1 and theta 2 for this system. In 3 degrees of freedom system, A and B and C diagrams. In A diagram, three masses and four springs are there. These three masses are displaced with different displacement, x1, x2, and x3. In B diagram, a compound pendulum is there in which m1, m2, m3 masses are displaced with different angular displacement, theta 1, theta 2, and theta 3. In C diagram, three rotors are there attached to single shaft and they are rotated again with angle theta 1, theta 2, and theta 3. In all these three examples, the displacement that may be linear or angular or system displacement depends on these three parameters. That's why it is a 3 degree of freedom system. Such n number of degree freedom system are there that you have to consider. That means what is degree of freedom? Number of variables or independent variables necessary to completely describe the motion of every particle in the system is called as the degrees of freedom. Now I think you understand that. Next, vibration parameters. All the
Hello, hello, students. Is it stopped?
Yes, sir.
You are not seeing it now?
Yes, sir.
Okay. Did you understand till this part? Did you understand till this part?
Yes, sir.
So, if any doubt, you can ask me. We will continue the next part in the next class. Better. So, if you have any doubt on the definitions and all, you can just ask me.
Sir, can you explain about the degree of freedom?
Sir,
Yes, बोलो.
Sir,
in natural frequency,
कोई एक दूसरा भी पूछा था तो एक एक करके पूछो तो कोई ऐसा
hello.
मैं
या टेल मी.
वो जो डिग्री ऑफ फ्रीडम है उसके बारे में थोड़ा एक्सप्लेन करेंगे क्या?
हाँ, definitely, why not? So, what is degrees of freedom? Look, so degrees of freedom means in what kind of direction or in how many direction a object or body can move. Okay, that means, wait, I'm giving you an example. Look, as we discussed here, a motion, any motion, suppose a body is moving. Can you all hear me? Hello, can you all hear me? Okay,
Yes,
just
sir.
pay attention. Just pay attention. Suppose a body is moving. Now its movement is being repeated after certain amount of time. So as you have seen in the presentation, it is called what? It is called vibration, right? Now that body for that body, the number of independent coordinates that is required to determine completely the position of all parts of the system at any instant are called degrees of freedom. Now, independent coordinate means what? That is an important thing. Now, what is independent coordinates? Look, independent coordinate means if you have, suppose, one coordinate, that means what? Single degree of freedom. Then comes if you have more than one coordinates, then it comes multiple degrees of freedom. Is it clear or not clear?
Yes, it is. But one more question about that in the same topic.
Hmm. Say. Hello?
Sir,
पूछो और कोई पूछ रहा था ना
yeah,
मुझे? तुम पूछ रहे थे ना?
yes, sir. And in DOF, degree of freedom, there is a sentence
Hmm.
to
But-
complete the motion, to complete describe the motion of every particle in the system.
Hmm.
What does it
Every
means?
vertical system means what? Suppose if you see a pendulum, okay? Now, if you are asked to okay, give an example of single degree of freedom, then you will say that it is a pendulum motion. Now, if you see in a pendulum, what happens? The body is moving to and fro in only one direction, yes or no?
Yes.
So, now if just try to imagine the one who asked me the question previous one also, you also listen it to it carefully. Now, if you can understand, now if you can see, if you invert that pendulum, मतलब pendulum को उल्टा करके लगा दिया, and now you try to vibrate it, then what will happen? The pendulum will move only in one direction. That is single degree of freedom. I am giving a practical example. Now, in certain cases, because of different frequency of vibration, the pendulum will rotate in multiple directions. Then that is multiple degree of freedom. सेम अभी क्लियर है तुम्हारे लिए?
उल्टा मतलब सर कैसे
उल-
उल्टा लगाए? हाउ?
पेंडुलम को क्या होता है? पेंडुलम का रस्सी को तुम हाथ में पकड़ के नीचे को बॉब को घुमाता है ना?
हाँ हाँ
तो अभी अगर वो हाथ का रस्सी का जगह वो स्ट्रेट लाइन हो और उसको नीचे में कहीं पे लगा दिया, मतलब लॉलीपॉप की तरह होगा, उसके बाद उसको
ओके
वाइब्रेट करेगा, समझा?
ओके
अभी समझ में आया?
तो
बोलो.
that means only one side. It cannot go side. It cannot go to the other side.
या जस्ट अ मिनट.
Move other side मतलब उसको एक तरफ जाने नहीं देगा बोल के ना सर पेंडुलम को. Then okay. So in natural frequency, how can a body create a motion without any external force?
नहीं, वो तो नेचुरल, अगर नीचे में मूवमेंट होगा तो मूवमेंट होगा ही ना, तो एक्सटर्नल फोर्स रहेगा ही, समझा? तुम लोग का कुछ डाउट है तो बोलो मुझे. Anyone having any doubt, you can ask me.
Sir, hello, sir. Can I say that in single body, single degree of freedom, the body is moving only one direction and about x direction?
Yeah, you can say that only.
So for this about the same basis, then in the third, the 3 degree of freedom, then body has to be moving for to all of the three direction,
There is only
means
one. Oh,
x,
look,
y, z,
one is
whatever
single
it is.
degree, one is single degree, then one is double degree, and the other is multiple degrees. Okay,
Yes.
so in that manner only. Yeah, you can assume in that manner only. Okay,
Multiple means we rotate the pendulum in circular form.
सर्कुलर फॉर्म पे नहीं, उसको अगर वाइब्रेट करेगा तो वो डिफरेंट डिफरेंट वे रोटेट होगा, तब तुमको मल्टीपल डिग्री ऑफ फ्रीडम दिखाई देगा.
Okay.